Okay, we are now officially recording. Okay, so this is Net Plus, obviously, and we're just talking about the troubleshooting steps. So the main thing that you want to do when you're going through any scenario is you want to identify where are you in the process. Okay, are you at the very beginning? Are you somewhere in the middle? Are you in a loop? Right, going back and forth trying to figure out, a theory of probable cause and testing it, right? Are you towards the end, right? Understanding where you are kind of helps you eliminate some of those likely answers that you see, because in a multiple choice, what I like to do is throw in multiple answers that could all technically be right, just depending on, the information given. Understanding where you are helps you eliminate some of those answers. Okay. So what I want you to do when you get presented in any scenario is just try to identify where you are, even as you're going through the process. Identify where you are, and then just kind of take a mental note of where you are as you're going through the process, and that'll help you kind of, if you do that enough, you kind of train yourself to do that, then hopefully you'll do that when you're taking the exam too, and that will definitely help. Okay, so you see this a couple times actually. Now they actually included this in A plus. So you'll see these steps in A plus. So the first thing is just understanding the order of things, just being able to put these in order. And then next you want to understand, okay, as you're going through any troubleshooting scenario, being able to identify where you are. And that kind of gives you a good indicator of what you should be doing next. Okay, so we're going to do a group activity right now. And try to use this process here to identify, what is it that we should be doing next, or, where should we be going with the next step. All right. So let me move this out of the way, and I'll bring this network over here. Okay. So real world scenario. Okay. This is 3 networks here. It's actually more than 3 networks. This is a network here. This is 1. This is actually 2, 3, 4, 5, 6. So there's actually 6 networks here. Okay, but we're just focusing on this one right now. Okay, so let's just create a scenario. Okay, this is like a department store or something. Okay. And this is our little section, whatever you want to call it. Maybe we can call it a marketing section, or whatever you want to call it. And let's say that it's been a weekend. Okay, so everyone's coming back from a long weekend, and in console over here, and here are all of your employees' PCs down here. Okay, so after, I don't know, been at work for a little while, not too long, and you're starting to receive calls from some of your employees stating that they cannot access this server over here for some reason. Okay. You have multiple people telling you that, and you don't know what's going on. So somebody tell me, this is a group activity. All right. So everyone's opinions, everyone counts. If you have an idea of what you would do, just shout it out. But we're going to do it as a group. So you can shout it out in the chat box. But after about the 4th or 5th call as an IT manager, you're starting to worry. So somebody tell me, what's the first thing that you should do in this scenario, given that information, right? I haven't calls, and people are saying that they're trying to access stuff from this server that's on another subnet, but they can't reach it. What would be the first step? Somebody tell me what you would do first.
See if you can replicate the problem.
Okay. So how would we do that?
By going up there and trying to use one of the terminals that are up there.
Well, we could do that, but let's think about the troubleshooting process, right? Well, we could actually go over to that subnet and physically check the server, right? But in the troubleshooting process, what is it that what is the process, I guess? What are we trying to do? What is obviously we're trying to fix the problem, but when you're first getting started, what are the type of things that you're looking for? Wayne says establish a theory, right? Let me put it to you this way. Are we looking for simple solutions or are we looking for complicated ones? There's an order of things, right? What would be the easiest thing to do at this point?
Check the routers and the switches.
Check the routers and the switches.
See if there's been any recent.
Say that again?
See if there's been any recent changes.
See if there's been any recent changes. Okay. I'm thinking even before that. So let's say that all of these devices, right? These are all different coworkers. They've all called you and told you that they cannot reach this server. What is the first thing that you're going to do?
Verify the server's turned on.
Verify is turned on. Okay. Even before that, Wayne says try to connect. Try to connect how, Wayne? I'm looking for something specific.
I'd probably try to ping it.
There we go. Right? They're telling you that you can't reach it. So one of the first things that you're going to do is you're going to make sure that you're having the same problem, right? That's the easiest thing to do. That would be the number one step. Try to ping the server, right? So let's give it a shot. Server's IP address is 2.4. All right, 168.2.4. So I'm at my workstation. Okay, I haven't. You know, all right, so what I'm going to do is I'm going to come into my command prompt from here, right? I'm going to ping 192.168.2.4, right? Destination is unreachable. So first thing you want to do is you want to verify, right? When people are telling you something, you want to make sure, okay, they're not just crazy. Maybe, something's wrong or who knows, or maybe, they're just tripping. But the first thing you want to do is you want to make sure that, yeah, there is a problem. You're having the same problem that everyone else is having, right? So we try to ping the server, and it appears to be down. What would be the next step?
Probably a trace route to see how far you're actually getting.
Right. Does anyone else have anything else that they would try? Yeah, I would probably do traceroute next, right? Because, well, even before traceroute, there's something that I would do before traceroute. Traceroute is a good one, but so the first thing I did was we tried to ping the server, right? The server is down, or for instance, it's unreachable. There you go, right? So before you go and you start doing the traceroute, right? You want to make sure that the problem isn't in your shop, right? Because if they're not able to reach the server, the problem could easily be over here, right? You want to start inwards and then go outwards. So the first thing that you should do before you trace route, right, is you want to ping your gateway. You want to verify local connectivity, right? It's the same thing. Verify that the problem isn't here, right? So next I would, let's come back here. We're going to go ping 192. Oh, wait. So let me come back. Does everyone know what the gateway is? No, right? So there's a couple ways to figure that out. I know what it is because I configured this network, but if I click on this PC, come back, right, I can go to the config and then I can see here, come to the gateway and say, okay, so the gateway is 1.1. All right. I don't want to skip steps because I think all of this is important. So yeah, go to your config, find out what the gateway is, verify it, that it's right. Okay. And then you ping that. So we're going to come back to the, and we're getting replies from our router. So what does that tell us? Somebody shout it out. Problem's not in our house, right? It's not over here. You ping the gateway and your gateway is good, and the problem's not here. Another way you could do that is you could ping another device on your network. Actually, that would just tell you that your switch is working right. You still be able to communicate with these devices, even if there was a problem here. You just want to be able to get out of the network. But so you shouldn't have any problems getting out of the network. So that tells us that the problem must be somewhere else, right? Once you realize trace route, right? So we know the problem isn't here. We want to find out where is it, right? If it's not here, it has to be somewhere else. Maybe it's between these routers. Maybe it's between this connection here. Maybe the server is just down. Who knows? But traceroute will give you a good indicator if there is a problem here somewhere, right? So that would be the next step. So we're gonna traceroute to 2.4, right? See what happens. First hop went like it should, right? So it's basically telling us that this connection is good. Then it's getting thrown back like just a little bigger. So it looks like it's just looping, right?
Tristan.
Yes, sir.
Hey, I got a question for you.
Go ahead.
I had my question was after we ping the gateway, do we ping the next router out before the server?
You could.
Or that's why we use traceroute?
No, you absolutely could. If you wanted to ping this router here, you could.
Right.
We can do it at the same time, as a matter of fact. So let me get this out of the way. I'll do a quick ping. All right, this is a quick ping right here. So I'll click here and then click here, and it went through. Right, it went through successfully.
Right.
So, but this is basically telling you that this is up. This is up and is ready to receive traffic. That's all that this ping is telling you, right?
Mm-hmm.
But when we ran a trace route, it seems like there's a problem over here at the same time because we're not getting past this router here for some reason, right?
Right.
So even though I just pinged it and it was successful, this right here is still telling me that the problem is probably somewhere around here. Does everyone understand that? Does everyone get that?
Yeah.
Okay. So what does that tell you?
What it tells me that the configuration for that router one interface is down, but one interface is up. That's what's telling me. But I have to know. I have to see the physical, the
The physical config, yeah.
yeah,
So
right.
yeah, you're definitely barking up the right tree. I don't want you to get confused though, because you said the interface is down. When you see these green lights here, that means that your interfaces are up. They're not only up, but they're connecting and they're ready to receive traffic, right? So two different things. You mentioned the config. Let me come back to this trace route right here, right? So we're gonna max out at 30 hops, right? It tells you right here, that's our TTL, time to live, okay? So we're at 27 right now. It doesn't look like it's gonna make it. So somebody mentioned that they wanted to look at the config. So why don't we do that? So here we are. Physical, right, config, right? And here are your different interfaces here. Okay, so we have three that are connected, right? We're kind of mainly concerned about this one here and this one here, right? So let's take a look. This says 4.1. Okay, I think this is this network going down here. This is your 4.1. This would probably be 5.1. 3, 4, 5, I believe. Okay, so not that one. 3.2 would be here, because this is a 3.0 network, so this would be 3.2. This looks right, right? This would be 3.1, and this would be 3.2 in this network, because this subnet match right here is only going to give us two addresses, right? So this is going to be the 3.1 and 3.2. This looks right, right? So it's probably not here. Let's take a look at the other one. Okay. What about this one?
Yeah, that's questionable.
Yes. Tell me why. Someone tell me why. This may be a little advanced, but this is good to know.
Well, it's the IP address is on a different network altogether.
Exactly.
I mean, because it's not a 192.168.4 network or .2 network. It's on the 7.
Exactly. It's on the 7.0 network, right?
Yeah.
This represents a 7.0 network, and we don't have a 7.0 network here, right? Would that kill the connection and stop any traffic that's headed towards the server? Exactly, right? And so there is our problem. So if we fix this, right, this is just a fat finger problem, and this could easily happen if someone is doing static addressing, right? This should be 2.1, right? And that will put that on this network. Then everything should work. So let's come back to our PCO here and to ping again. And 2.4. It's taking a while, right? First one timed out, but it went through. Right, it took us a second for the config to actually go through, but so that fixed our problem, right? And everyone over here should now be able to connect with the server now. We just had a problem over here. Someone was making some changes. Unauthorized person was in there messing around, and they made some changes that they shouldn't have made, and they messed up the network. But that's the process, all right? That's the thing that you want to do. You want to start with the simple stuff and then kind of narrow it down and, and that's how you do that, right? You um, start with the simple stuff, right? Start with pings, and, first ping the whatever device is in question, ping it, make sure it's up, make sure that it's not reachable, make sure that it's not just something that they are experiencing on their own, right? It's something that is universal. And then that kind of lets you know that the problem isn't in your house once you ping your own gateway, right? And then from there, you trace route and then you can figure out what's going on. Now, in most situations, that's probably not going to happen, right? It could have easily been something else, right? Maybe there was a problem with this interface over here, right? It could easily been that. Maybe the lease was up, right? Maybe they didn't statically assign this address. The lease was up, and everyone is trying to contact an IP address that's been changed, right? It could have easily been that. But the process is the same. You start with the easy stuff. You start inwards, and then you work your way out. And then from there, you try to figure out what your problem is. All right. Any more questions on that activity? And that was a good one. The person that asked me if you ping this router over here, because you could have easily bypassed this whole router by doing that. You know what I mean? Because let's say that we just kept pinging. We said, okay, we're going to ping this one first. Where'd it go? Over here. Right, so let's say that, I started this ping here, the ping went through, and I said, okay, let me ping the next one. Right, so ping this one, it went through, and you can easily just bypass it and say, okay, this router isn't the problem because you pinged it and it replied. But just because the router is up doesn't mean that it's configured correctly. So you gotta always remember that. Don't get confused.
Can we expect some labs like this on the exam?
So at the beginning of the exam, there are a few, I call them performance-based questions. They're not going to be like this. Okay, I mean, they may ask you to, it may be something like this. They may ask you to configure a couple routers, right? With simple stuff. I don't mean like, they may ask you just to, put in the SSID, the password, the encryption, that type of stuff. So you have 3 routers that are in close proximity. What's one of the things you want to look out for when you have 3 access points that are in close proximity? Nobody? Anyone want to take a guess? Yeah, there you go.
Yeah, overlap.
Right. So you can get one like that where they want you to configure multiple wireless access points. These are obviously to worry about that. But in that, on that lab, they'll probably have a few routers in close proximity. I remember seeing that in a question like that. And so you just want to configure them with the information that they give you, just the simple stuff, and make sure that you're watching the channels, right? You don't put any duplicate channels next to each other or anything like that. Another one they could give you is the antenna placement one, where they want you to actually they give you like a building or a couple buildings, and they want you to put the correct antennas in the right spots. So, and the whole thing is you want to maximize the signal, within the building. You want to minimize the leakage outside. So this requires you to pick the right antennas for the right places in the building. What else is another one? Cider is another one. They could say, give you something like this where you have 3 different departments. So let's say this is your marketing department, this is your sales department, and then you have an IT department. And they tell you how many devices you need for each of these departments. And then from there, you decide which subnet mask you're going to use. Because in this scenario right here, in this network, these are actually, you wouldn't use these subnet masks. This is way too many devices, right? I would probably I'll probably cut these down, kind of like I did with these, right? So these are point-to-point connections. That's why you see different subnet masks here, all right? So this one here is a /30. These two, this connection here is a /30, and this is to all three of these. So I just didn't write these out, but that's how you want to structure your networks when you're talking about CompTIA. They're always going to want you to use the most efficient subnet mask. So in this instance, I will probably, how many devices do I have? 1, 2, 3, 4, 5, right? So I'll probably use them like a /29 here, same here. In a real world scenario, you wouldn't, because every time you hire someone, you're going to have to come and change the configuration. So you're going to plan for expansion in the real world when you're designing networks. But for CompTIA purposes, you're going to keep them as small as you can. So in these instances, I would use a /29 on these devices, on these subnets. Okay, past 10:02. Oh, congrats, Wayne. Glad to hear that. Right.
I just passed 10:01 on Wednesday.
Oh, awesome. Great news. You may want to talk to Wayne. All right. Okay. Let's see. Other than the first few questions, you're not going to see many questions like this. The majority of the exam is going to be scenario based. It's going to be the same type of scenario that we just went through, but I wanted to just use this diagram to actually do it. Right. So that exact scenario that I just gave you could easily be a multiple choice question, right? And obviously they would give you more information, and then they would have, a bunch of answers that could, there's going to be at least probably 2 of them that could actually be right, but it more than likely the question would be, they would give you this scenario and be like, what's the first step? So first step, trace route the server, ping the gateway, ping the server, or, check to see if the server is plugged in, right? And you would have to choose from those 4. All of those are all viable options, right? But from a CompTIA perspective, the question would probably say, what would be the next, or, what would be the first step? Or, what would be the most feasible step, right? What are you going to do first? And in that instance, you're going to ping the server first. From there, you would ping your gateway, and then from there, you would probably trace route. Okay, so yeah, CompTIA, like Kelly said, CompTIA really likes to order the steps, so you just want to make sure. That's kind of the purpose of going through this activity. I wanted to go through it, so you know the steps, and then also look for keywords in the question, because if they tell you, they give you that same scenario and they say, you verified local connectivity, it's the same way of saying that you've already pinged your gateway. You know that the problem is in your building, or it's not within your network, right? So from there, they're telling you that you don't go backwards from there. So pinging the gateway and pinging the server have already been done. In that instance, you would go to the next step, which would more than likely be trace route. All right, so it's about the order of things and understanding where you are in the process, right? So let me come back here just for a second and just kind of show you. So gathering information, right? The first thing that we did was duplicate the problem. Somebody said that too, right? I think they said duplicate the problem, or figure out if you can duplicate the problem, right? It's going to probably be your first step. Gathering information is when when people are calling you saying that they can't reach the server, right? They're giving you information, and then from there you check and see if you can get it yourself, right? So identifying the problem is just the first step is saying, okay, there's a problem with the connection to the server, right? The next thing is why. Establish a theory of probable cause, right? Why? And then that's when you start trying to figure out, all right, what is the problem? So as we were going through, we pinged. So the first thing we did was ping the server, right? So we tested the theory, or we duplicated the problem, right? And our theory was just to see, okay, is it up? And it just can't reach it or what? So we tested it, didn't work, right? So we came back here and we're trying to figure out why. Consider multiple approaches, right? So what's the first thing that we did? From there, we pinged our gateway, right? Gateway worked. So that's actually tested, right? We're saying, okay, well, is it the gateway? And by establishing the theory is asking if it's the gateway. Testing the theory is pinging the gateway, right? Once we ping the gateway and it worked, now we can't go forward. We have to go back, right? So let's say that we pinged the other router, right? That router worked, right? So is it the other router? Establishing the theory probable cause. We tested by pinging it, right? And it worked. So you come back, right? And then once we did trace route, right, we figured that the problem is outside of our network, so we did a trace route to figure out where, right? That's testing the theory. And then we found out that there's probably a problem with this router over here, or the configuration. The router is up, but maybe the configuration is wrong, right? So we went into the configuration, right? We thought maybe it's the configuration, something's wrong with the router, and we tested it by going into the router and looking at the configuration. And we figured out that it was wrong, that the gateway was wrong. From that point, now we're moving forward, right? What's the plan of action to resolve that? You just change the gateway to the right one, right? So we corrected it. We don't need to escalate because we figured it out. Then you just verify full system functionality. We did that by running the ping again, right? And then from there, you come here and we document findings. We just say, okay, put a password that doesn't allow people that don't know what they're doing. I wanted to use another word, but I forgot we're recording. So document findings and actions and outcomes, right? You know, maybe put a password on there that doesn't let just anybody come in there and change configurations, right? But the whole thing is, you know, you go through this entire process and understand where you are and what you're doing, right? So any other questions on troubleshooting or the activity that we just went over? Nope. All righty. Well, that's it for me. What do you guys have for me? We still have 20 minutes. So Wayne says the slash. Do you have a question about the slash, Wayne? Yes, in the /24. Okay, what's your question?
Still learning. You look at the IP address, you have the 192.168.1.0, then the slash. Just taken, so it's not. I wasn't familiar with that term yet. I haven't gotten training yet. So you said your diagram shows a /24. You mentioned maybe 29 to me for expansion later. Trying to understand that concept.
Okay, so it's not easy to explain, not from not from here. Okay, so for /24, what this slash does is it really, all right, so let me open up a document that'll help explain it a little better.
Doesn't it basically identify the size of your network?
Yeah.
In simple terms.
Wrong one. Let me find the other one. This one right here. Okay. All right, so I'm gonna use a document that I've been using for a while to help you understand this a little bit better. Okay, so this is your /24 right here. Okay, this is your subnet mask in binary. Okay, so this is what it looks like. From IP perspective, this is what it looks like in binary. Yeah, exactly. This is how it looks like for us. This is how it looks like to the computer, right? Okay, so this is in fact a /24. All right, this is the same address that we were just looking at. So let me bring it back over just so I can show you, right? We're talking about the same, right? This is the same address. So what I'm going to show you right now is the relationship between the host on this network. All right, so this /24 means that the first 24 bits in this address, which is represented by yellow here, are all ones. Okay, this means that they're being masked. Okay, this is the portion of your network that remains the same. So, for instance, or I'll just, it's in yellow, so it should be pretty easy to comprehend. But this is the portion that never changes, right? And then this portion over here, this is where you get your 1.1, and then 1.2, 1.3, right? The green is the variable, the yellow is the constant. Okay, so this represents the amount of hosts that I can have on a network, right? So the more masking that I have, right? So I'm going to add a couple more ones here. The more ones that I have, the fewer hosts that I can have on my network, right? Because now I have more constants, right? In this instance, this would be a /28, right? 24, 25, 26, 27, 28. Let me turn this yellow real quick so it corresponds. There we go. This one too. Okay. So now I have a /28. Okay, and I'm going to show you what this looks like. This should be 240, right? I believe 128, 192, 224, 240. Yeah. So that's what this would look like now. Okay, and this is the /28. So in this instance, now I have less hosts available. So this is how you control the size of your network, right? By doing this. So if someone comes to you and says, I need a network that allows for 30 devices, right? Let's say that we need 30 devices. Well, now I can structure my network with the subnet mask to accommodate 30 devices and nothing more, as opposed to having this, right? This gives me 240, oh, no, I'm sorry, 256 addresses, but it gives me 254 hosts, okay? Because there's 2 addresses that are always excluded. And that's the first address, which is this one here. This represents your subnet. And the last address, the very last address on the subnet is reserved for the broadcast address. So those are not usable as hosts. So even though this gives me 256 addresses, it only gives me 254 hosts. Okay. So basically, and I know you're just getting started with this, so I'm not going to go too much into detail. I'll let you kind of, view a couple different sources of this information. I'm just kind of explaining to you how the relationship between the masking and the host, this is basically how you structure your subnet and decide how big you want it to be, right? It could be as small as just 2 devices, right? Like right here, this is a /30, right? 252. And so let me show you what that would look like in binary, right? That would look like this. I think that's right. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's right. Okay, so that would look like this, right? And so 252, right? And the reason that I would do this is because in a network like this, I don't need a bunch of devices. If I have extra addresses, it's just extra ways into my network that I don't want. So in a point-to-point connection, I would want to minimize the amount of available addresses that I have. And so that's why I would do this. I would use a /30 because it's only going to give me 4 addresses, and I can only use 2 of them. Since I can't use 3.0 and I can't use 3.4, I can use 3.1 and 3.2, which are these. All right. Does that make sense?
I think you commonly see those on serial cables, right? Because you can't get as many.
Right. Or in any point-to-point connection, a lot of the times you'll see a /30. Because if you're just connecting a router to another router, then you don't need 256 addresses, right? You only need 254 hosts. So you just use your subnet mask to structure your subnets when you start to split up your networks. You just do it efficiently, right? So, go ahead.
I was wondering, why did you set the network up the way that you did? Do you have time to do a little run through and tell us, when you put this together, where would this type of scenario exist in the real world?
Okay, so your question was, why did I set this up the way that I did?
Yes.
The answer is, okay, so the answer is really simplicity. This is really just a mirror. This network, it looks like a triangle, but it's just a mirror, right? You have a router that's connected to a switch, and you have some end devices here, and you have the same thing here. Router connected to a switch, end devices. Router connected to a switch, end devices. And then, once you have them set up, and then you just figure out how you want to connect them. So you could do it statically. You could set up static routes, or you could use dynamic routing, which you would probably want to do. Once you have multiple networks, you probably just want to use dynamic routing. But this was just created this one time we were doing the Net Plus session, and I just decided to build a network from scratch, and I just never deleted it. Every time I want to reference a network, I just keep coming back to it.
I mean, why would you use the 3 routers the way you did instead of just one between all 3 switches? Are they set up for load sharing?
You said, are they set up for what?
Like load sharing, round robin load sharing? Why would you use 3 routers instead of just one to handle everything?
Well, one router is a single point of failure, right? So I want to use 3 just in case one goes down. You want to have continuity, obviously. Right? You don't want the whole network to go down just because one router goes down. But the main reason I have these multiple routers here is because I wanted to show, how to connect them, how to distribute traffic between them, how to set up a DHCP server on one and use another one as a helper, right? How routers work in conjunction with each other. So if I come here, I'll go to the command line real quick just to show you, but if I do show run, right, show run command, you'll see that this router here, this is it hosts the DHCP pools for all 3 networks, right? So I have 3 networks that are sending DHCP requests, right? This would be one, right? This would be another one right here, and then the third one would be this one down here, right? So here are your address pools right here, okay? So this router right here is actually serving as the DHCP server, okay? But all 3 routers can't. So that's another reason that sometimes you want to use multiple routers, is you want to show how in situations like that, you would make one of the server, right? And then if I come over here, you're going to see something. Who knows the term that identifies a router as a relay for DHCP? Does anyone know?
I do know, but it escapes me at the moment.
It's helper.
That's right.
So if you look at the configuration of a router, and you see, where is it? It's got to be here somewhere. Access list. Where is it? Here it is, right here. Right, IP helper. So if you see and there's also identifies the address. So what this is doing, and this is just FYI stuff, all right? Because you do need to know that the helper address is going to relay to the DHCP server. Okay, so for but what this is saying is that this router here, if it receives a request, a DHCP request, it's going to send it to 3.1, right? Where's 3.1? 3.1 is here. So if I added a new device here, right? If I added a new laptop and then I turned DHCP on, right? It would come to this router here, and then this router would send it, IP helper address, right? It would send it to 3.1 over here to receive an IP address, and it would come back over here. Okay? So things like that. That's why you want to add extra routers sometimes when you're setting up a network. One, I just wanted to do a mirror of these three and then connect them all. But two, in some instances, you want to be able to show how they work in conjunction with each other. Another thing that you want to do is set up multiple switches, and then you can see how spanning tree works. If you set up more than three, actually I think you just need three, right? One of them is going to cut off one of their connections. Who knows why? Switching loops, right? If I set up three switches here, right, and they look just like this, more than likely this connection here, it would appear differently, and the reason is to prevent switching loops. That's what spanning tree does, right? If I were to activate this connection over here, by default, one of the other ones would switch off if spanning tree is running the way it's supposed to be running, because if you have all your connections good and you get a switch loop, it's just going to keep going like this, right? And so what you do is you make sure that traffic is only going one way, and that's how you prevent the switching loops. That's another chapter. That's another day. Don't have time to talk about spanning tree, but it's important to know that for Net Plus too. You want to, at the very least, you want to know that spanning tree protocol, or STP. The main purpose of it is to prevent switching loops. Alrighty. Any other questions about the network and why it is? I think you had another one, right? No? Yeah, to be honest with you, when I first started, when we first started putting this network together, there was no real purpose to it. I just wanted to kind of start from scratch with the connections. And then, we did some basic. I'm getting back. Oh, wait. Was that you, Daniel? Go ahead.
Yeah, sorry, my mic is malfunctioning here, but yeah, I was just kind of wondering, in the real world, if you would see a setup like this. Because it's kind of unfamiliar to me, so I was just curious.
More than likely you wouldn't, because this is set up this is set up physically, right? Meaning that this LAN here, all the switches are connected to this. All the switches, all the devices are connected to the switch are in the same LAN, they're in the same subnet, right? This is kind of an old school setup, right? The other thing is all this stuff is wired. In today's world, you would probably see a lot more wireless activity. You're not going to see a lot of wired stuff. And for the most part, your subnets are going to be split up logically, not physically, because you're not going to have the whole marketing department working in the same building. A lot of the times you have people from sales and marketing working right next to each other, right? So, in the real world, you would see a more logical setup than a physical one. I just did out of simplicity. This entire network is wired. Right? You don't see that often.
That's
Maybe
that makes sense.
What's that?
I said, yeah, that makes sense.
Yeah, I mean, the only time you probably see something like this is maybe like in the server room. And then, you know, you may have a bunch of, you know, you can have a bunch of Ethernets going out to a switch, but for the most part, in the real world, you're going to see wireless. We're in a wireless world. No one wants to be tethered to anything anymore. So, but I mean, there's still some offices that do it old school. Some people are taught a certain way and they're just comfortable with how they were taught things. So it just kind of depends on who you have running stuff. But okay. Any other? Let's see what this will look like. Yeah. See, this isn't. So this is kind of what you would see like in the server room, right? These are all the these are all the devices in the network, right? So you have a switch. We have Raider 1 and Raider 2 down here, which are our routers, right? Then you have a server here. Another switch. Where's the other server? There's 2 servers, right? Maybe in another room or something. But so typically, if you went into a business that had that kind of setup, it would look like this when you're on the server room, right? This is what it looks like logically, right? And then physically, this is what it would look like. So, and you can actually see with Packet Tracer, you can actually see the ports that are plugged in, right? They're all right here. And if you hover over them, it'll tell you which device it is. You can see the actual activity, right? The blinking green lights. That's why this is a really good tool.
Oh, that's very cool.
Yeah, it is. Because it organizes all this stuff for you. Like, I didn't do this. All I did was just drag the stuff out here. I just drag it out here and then connected it, right? But then when you go here, it does this for you. It's a really good tool to use if you're trying to understand networking. And I'm going to tell everyone, like I was told when I was, you know, trying to figure this stuff out, and I asked, I said, well, you know, what's the best way to learn this stuff, to understand it? And they said to play around with this stuff. You know, find an environment where you can actually put the stuff into action. You know, and then it's not just concepts anymore; it's memory. You know what I mean? So there's no substitute for actually doing something. I don't care if you're someone that learns from reading. There's no substitute for actually doing something and seeing it done and, you know, physically doing it. Because now you have muscle memory to go along with it, right? To go along with the information. Sometimes information is enough, but
I will say for myself that taking the 1001 test, I discovered sometimes having real world applications or experience actually made it more difficult because it's like, I know this is how I would really do it, but what's the book say is the right way to do it?
yeah, it's like I was saying with the addressing schemes, right? In the real world, I probably wouldn't have this many devices, right? Because this gets me 254, but I would definitely narrow this down, right? For CompTIA purposes, you know, you want to be right on the dot. You know, you don't want to plan for expansion. So you just have to keep that in the back of your mind when they're asking you about, they give you a question and they want you to kind of determine which, you know, which slash you're going to use for any department. You're going to come as close to the number they're asking you for as possible. But in the real world, you're always going to plan for expansion because you don't want to have to reconfigure the network every time you hire someone or fire someone. You know what I mean? So.
Well, also like troubleshooting for the 1001 is mostly hardware based. And I'd say 90% of the time, the first thing you do is a reboot on the OS because it's quick, easy, and it fixes 75% of what's wrong. But according to CompTIA, that is not the first thing you do.
Right. Right. And that's true. I mean, sometimes in reboot, I guarantee you, a lot of the times it'll be one of the answers. You just have to pay close attention. Sometimes you're just looking for the simple solution, right? It's like, why reboot if a restart will fix the problem? Sometimes a restart will fix the problem, right? Sometimes we have updates pending, and the restart is what completes the update, right? So sometimes you just have to close out an application and restart it. You know, there's a lot of things that doing something else can fix outside of a reboot. So you just have to know when reboot is appropriate and when maybe there's a better answer. That's what it boils down to. It's just, even though you know something works, sometimes there's a better answer, and that's what they're looking for. You got to be very careful with troubleshooting. That's why I wanted to go through the process. Just start with one, then go to the next one, and go to the next one, because that's what they're looking for, right? They want to know that you know where to go from where you're at. Recognize where you're at, and then know where to go from there. All right, I don't want to keep you guys too long. We are at 11 a.m. my time. So let me get the names down. Are there any other questions, concerns about this stuff? By the way, this is a free resource. And it does give you access to all of this, to all of these routers and these PCs, this network stuff. There's a lot of other cool stuff that I didn't even mention that comes with this resource. But I wouldn't recommend it for Net Plus. There's another one. I would recommend the hands-on simulator through Pearson if you're going to be taking Net Plus, because that's more of a teaching tool. And a lot of the stuff, the configurations that you have to do, they walk you through it. Here, you just have to know it. So unless you're on YouTube and you're just following what someone else is doing or something like that, that's cool. But the Pearson, the hands-on simulator from Pearson is more of a teaching tool. You know, walks you through how to do a lot of the stuff, some of the stuff that I was doing today. So I would recommend that more for Net Plus than this. But this is a good tool because it's free. And it lets you practice the concept. So to me, either one works. Okay, where is my? Okay, bear with me for just a second. If anyone needs to take off, go ahead, just leave your name in the chat box so I can get it before, so everyone gets credit. Ryan. If you guys have any other questions, go ahead and shoot.
Yeah, what's up?